Let's explore how Riemann sums approximate the area under a curve. We'll use rectangles to estimate the area under this parabola. We want to find the area under the curve from x equals 0 to x equals 4. This is the region we'll approximate. First, we divide the interval into equal subintervals. Here we use 8 rectangles, so each has width 0.5 units. Now we create rectangles using the left endpoint of each subinterval to determine the height. Each rectangle approximates the area of that section, or units. We use what happens with 16 rectangles instead of 8. Let's see what happens with 16 rectangles instead of 8. Exact area under this parabola, about 10.67. Add more rectangles. Rectangles we use.
That was generated through a single prompt, no editing, no diffusion models used, but it was just a bunch of LLM calls and done internally that solved its compilation and errors and then rendered a visual like this with Python. If you ever tried to make explainer type of videos through Sora or Google's Veo 3, you would have realized that sometimes the faces are really good. It's really good at making faces, but sometimes the text does not seem to be accurate, and sometimes it doesn't make any sense, and sometimes the text are just a bunch of squiggles, right? As we can see here, I asked it to generate me a video of Pythagoras theorem explanation, and then I got this.
Any right triangle
okay,
with
that's
sides
great.
A, B, and C.
What you would have realized in this part of the video is that the squares are not correct. Like, this sort of a square should have encompassed the whole area, and why are there 3 squares over here? So this is one of those places where diffusion models really suck, because diffusion models are generated or trained on pixel level. So how does diffusion models and Animo differ? So diffusion models generate basically pixels. They start by adding some noise and then add a little bit of more of noise, and then you get the end result. But sometimes if one section is wrong, the whole thing can get wrong and messy, right? And in case of Animo, you basically ask the LLM a certain prompt, which is done internally from additionally from your prompt, and then you get a code which is reiterated back over if there is some sort of issues, and then you get some sort of visual frames, and that's rendered into video. So that's as simple as that, and this is comparatively more deterministic in nature, as you can see with the Riemann's some approximation video compared to this one, and also something like Pythagoras theorem, which I had generated as well. Although there is a problem over here with the right angles angle should have been over here. So anyways, these squares look to be in its correct position when compared to something like the one generated by Google, right? This looks really good, but then what is this? Like,
draw a circle and its diameter. Bisect the radius to find its midpoint. Draw an arc to define the side length. Mark the 5 vertices around the circle.
So you would have seen right now is that he uses 2 compasses over here, and it doesn't make any sense, like, right? I mean, maybe it would, but what is he doing here? Right? So, but at the end, he happens to go about
connect the points to form
connecting the points to form a pentagon all of a sudden, which doesn't like follow up the story. And the one that I generated on my Animo tool, you get something like this.
Let's construct a regular pentagon using only a compass and straight edge. We'll start with a blank canvas and draw our central point O. Now we draw a circle centered at O with a moderate radius. This will be our base circle C1. Draw a horizontal line through O, extending beyond the circle. The intersections with C1 are labeled A on the left and B on the right. Next, we find the midpoint M of segment OB and draw a vertical line through O, intersecting the circle at points P above and Q below. Draw a circle centered at M with radius MP. This circle intersects the horizontal line at point N to the left of M. Watch as we construct this key measurement. Now we draw a circle centered at P with radius PN. This intersects our main circle at 2 points, V1 on the left and V5 on the right. These are our first pentagon vertices. Continue this process, using the compass to mark equal distances around the circle, finding vertices V2, V3, and V4 to complete our 5 pentagon vertices. Let me show you the the remaining vertices. Finally, we connect the 5 vertices V1, V2, V3, V4, and V5 in sequence to form our regular pentagon. The construction is complete. This elegant method uses only compass and straight edge.
So as you saw, that was just more better when compared to the one that was generated through a diffusion model, and it gave you more accurate steps. And yes, it cannot generate faces, but it can probably give you much more accurate answers or videos or visuals for tutorial type of videos. Maybe you're stuck at a topic and that's really hard for you. You can just come up here and then generate a video that's going to be really easy for you to understand so far.